So now I would like to introduce our next speaker, our keynote address. And we are very lucky today to have with us Steve Schmidt, who is, backwards, who is our Vice President of Security Engineering and our Chief Information Security Officer. Steve is a fantastic representative for this audience in particular because he is almost at 7 years with the company, so he's been really with AWS since the beginning. And then also, before that, he was in the federal government, so he worked with the FBI before he joined us. So please give a big round of applause for Steve Schmidt.
Everyone, and welcome to the AWS Symposium. This is somewhat of an extended birthday celebration for Amazon Web Services as a company. We've been around serving the public now for about 8 years, which is pretty incredible when you think about this industry's lifetime as a whole. We started in 2006 with the launch of Amazon Web Services Simple Storage Service as a first step. In 2011, we announced about 42 new features or services across the company. And if you think about the velocity of change, we're now at a point where we're going to have almost 240 new major services during this year alone. So it's an incredibly rapid growth in an industry that's just exploding, and we're really, really proud to be a part of it. Now, today, we're going to spend some time talking to you about AWS and engaging on a bit of a learning journey with you while you're here. Give you an opportunity to learn more about Amazon Web Services, and at the same time, learn from our partners about how they can help you in your journey to the cloud. Additionally, something that's really important to us as a company is we want to learn from you. Customers drive our roadmap. They drive what features and services we produce. So it's really important that we hear your feedback and we understand what it is you need from a cloud service provider. Now, AWS is a company that's driven by its customers, and many of them you're going to recognize. Originally, in the beginning of the corporate growth for AWS, we were largely driven by startups, whether it be Pinterest or Instagram, Airbnb or Dropbox. These are all companies that are probably household names for you now, but in the beginning, they started off as very small shops, organizations with just a handful of people. And one of the reasons that they're able to be successful is because we gave them a very easy on-ramp to get infrastructure without a lot of capital investment. The same thing is true for enterprises. We have hundreds and hundreds of thousands of large companies who are running on AWS today, and they're also represented by household names. So whether it's Royal Dutch Shell or General Electric, Qantas or Samsung, they all operate on AWS, using our infrastructure to serve their customers directly. And of course, the reason that we're here today is to talk about the public sector, government, and education. AWS has a very broad swath of representation from the public sector and government. We have more than 800 government agencies that run on Amazon Web Services right now, more than 3,000 educational institutions that operate on AWS serving their students. Now, the fun part about this business is that it is truly global. And as some of our staff like to say, we're heading towards intergalactic. We're not there yet, but we're working on it. If you think about the companies that are operating locally, it's people like the Department of the Navy, but we're also really proud to serve people who are operating outside of this world. NASA JPL operates the Mars rover, and they run on AWS. Now, customers have told us that critical to their success is access to system integrators, people who can help them move their infrastructure and operate their infrastructure on a cloud environment. So if you'll note on there, we have system integrators of every type available for our customers now, whether it's the big names like Accenture or Deloitte, or the cloud-first folks like NordCloud. These are all companies who are dedicated to helping our customers operate successfully in AWS. And operating in AWS also involves access to software. The software that people want is the same software they want in their on-premises data centers. Whether it's business analytics from SAP or a database from Oracle or IBM, or it's control software from somebody like Computer Associates. The same software people run on premises is available on AWS. The key difference in many situations is the licensing model. While for most of those software vendors, you can bring your own license to the cloud if you already have it, in many cases, you can also buy access to software by the hour, something that's not traditionally available in an on-premises environment. All right, so why are people moving to AWS so quickly? Why do they adopt the cloud? The number one reason that we've been told by our customers that they adopt the cloud is agility. Agility is all about being able to change direction quickly. So why does agility matter? It's pretty commonly understood that agility matters for organizations like enterprises. Businesses change. They change direction dramatically. They change direction quickly. The winds of consumer sentiment sometimes push them to modify what they're offering as a service. So running on a cloud environment like AWS allows them to move from an environment where requisitioning a server from an IT organization might have taken 6 to as bad as 25 weeks to an environment where customers can have spin up servers in minutes in most cases. Now, what does that mean? It means it changes the way your staff thinks about IT. In the old world of IT, most of your staff had this sort of learned ambivalence about the process of innovation. Well, I'd love to try out this idea, but it's going to take me months to get a new box to try it on. And then what happens if it doesn't work? Then I get in trouble for having this machine that's sitting over here in a corner and not being used. In a cloud environment like ours, you can spin up new virtual machines, new storage, databases, et cetera, really rapidly and innovate, try, experiment. And if that experiment doesn't work, you can give the resources back and stop paying for them. They're no longer this boat anchor that's hanging around your neck. Innovation is something that is often an experimentation process. It's trial and error. Give it a shot, see what happens. One of the things that I learned when I joined Amazon was that in a company that innovates as rapidly as Amazon does, the expectations are different from a more traditional environment. We expect some experiments to fail. The key is to get them to fail quickly and cheaply if they're going to fail. And cloud environments allow you to do that, whether you're in the government or whether you're in the private sector. Now, when we're talking about Amazon Web Services, we're talking about a platform of services, a platform of capabilities, of software, and of people. All of those are underpinned by the ideas of regions, availability zones, and POPs. A region is a geographic part of the world in which your machines, your data, your databases, et cetera, sit. Unlike some companies, when you place your data in Amazon Web Services, it stays where you put it. We don't do global load balancing. When you put your data in the US East region, for example, it stays in the US East region. That allows our customers to meet compliance and regulatory goals, whether they be a European customer whose data has to stay in the European Union for PII reasons, or a US government customer who says my data must stay within the US and has to be administered by staff who are US persons. We have 10 regions around the world to allow customers to have low latency access to their data and their services from all of their customers, and 26 availability zones. An availability zone is the customer visible equivalent of a data center. I say equivalent to because in many cases our availability zones are so large they're encompassed by more than one physical building. What does all this mean? It means that customers can construct their environment to meet their particular availability and durability goals and spend the minimum amount of money necessary to do so. If you have a dev and test environment that doesn't need high availability or redundancy, you can put it in one availability zone. If you have a production environment that absolutely has to be up and running, you can put it in multiple regions around the world if you wish. So on top of that region concept and availability zones, we layer our services. These start off with the things you'd expect, like compute. EC2 is our virtual machine environment. We have load balancers that allow you to distribute connections that are coming in from your customers around the world to individual machines. And auto scaling that helps you ramp up your environment to deal with increases in load but then as equally as important, allows you to ramp down the environment and save yourself money. Storage goes hand in hand with compute, whether it be the virtual block store like EBS or an object store like S3. And then databases, of course, where everybody wants access to the same databases that they used on premises, whether it's SQL Server or MySQL, Oracle, or DB2. On top of that, we layer networking. Virtual Private Cloud is our infrastructure component that allows you to carve off a piece of AWS and make it your own. It allows you to define a set of networks, how they interconnect, the rules, the firewalls that go in between them, and the routing that packets take. Direct Connect is a way that you can link your data centers directly to ours without going through the public internet, ensuring that you have a path that meets your regulatory requirements, as well as low latency and low jitter, and high throughput. On top of that, we start adding more value. These are analytics services like Elastic MapReduce, or Redshift, which is our business intelligence database, or application services that are fundamental to allowing you to pin different pieces of your infrastructure together, things like a queuing service or a notification service or a content delivery network like CloudFront. All of that has to be orchestrated, so we have a management and administration layer that consists of our identity and access management stack, secure crypto key storage from Cloud HSM, and of course a management console. And we talked earlier about how our customers were demanding that we provide them with partners who are tightly integrated with us. On top of this all, you add in our partners. They're the people who can help you join together the components that we provide into a delivery framework that allows you to meet your particular mission needs. They can help you deliver services, or they can simply help you architect the environment you want to run yourselves. Now, we have people who we put on top of this entire pile. Our support team, the folks who are there 24/7, 365 to answer your calls, your email messages, and your tickets. And our professional services staff, who can help you make good decisions about how to architect your environment and how to operate it. We have training and certification available, of course, so that your staff can be proficient in their use of AWS services, ensuring that they're delivering what you need and ensuring that you're paying the least necessary to do so. Now, across all of this, security is our #1 priority. It's the reason I'm up here talking to you today. Unlike a lot of businesses, we don't have a physical location that you can visit. We don't have an environment where we hand you a physical good in exchange for money. All we have to serve you with is our virtual environment, which means that we have to get the security of that environment absolutely right. Now, many people are confused about security in the cloud. They think that somehow it's this magic different thing from what they're used to using. In truth, it's composed of the same kinds of security processes, people, rules, procedures that you use on premises now, just applied in a different way. So for most people, this is a very familiar place to start. We do the same things that most organizations want to. We do the same things that most organizations aspire to. You'll note that I said want to and aspire to, because one of the things that's different about AWS than most environments are, because we are a completely virtual organization, we have to invest the money necessary to get security right. So we have had the opportunity to invest in security staff and security procedures and security systems that many people don't have the money to do so. The good news for customers is that the big guys out there, whether the US government customers or General Electric or NASDAQ, drive a very high security bar. And we apply that security bar universally across our entire platform. So the student who's using our free tier to do their homework in their university dorm room gets exactly the same security capabilities the Department of Navy gets. That's a fantastic enabler for a lot of organizations. They get access to skills, to capabilities, to tools and controls that previously were not available simply because of cost. The net result is the analysts are telling us that people are now moving ahead with incredible pace at moving into the cloud. Gartner said people are skipping years of getting their feet wet and immediately jumping in with more significant projects, with more ambitious goals. They also said that increasingly organizations have flipped their mindset. No longer are they in a position where they're saying, well, what can we move into the cloud? But they've inverted that. They're now at the location, now in the mindset, and the US government is in fact in the same mindset in many cases. Tell me what can't go as opposed to what can. The net result then is we are now in a position where we've moved into a truly mainstream adoption of the cloud. And this is a real shift. It's a real technology shift. It's a real thought shift. And for me, it's the largest technology change that's occurred in my lifetime. It's we're getting away from this concept of I have to own, operate, control everything to run my business to I don't want to think about that. I don't have to think about that. I can be better off having somebody else do that heavy lifting for me. Now, thinking about security in the cloud, security is something that is shared. If someone is telling you they've got this magic security wand that's going to solve all your problems and give you the solution that you need, perhaps you should look into their details a little bit more thoroughly. Security is something that you have to do hand in hand with your service providers. If you think about the universe of what has to be done to keep your systems safe, and that what has to be done, by the way, is dependent on your workloads. We have some customers who are serving data to the public. They want that information to get out there. We have other customers who are the entire opposite. They want to ensure their data never sees the public eye. But they all have the same universe of controls that have to be applied. When you work with AWS, you work with us on security. We do a lot of the undifferentiated heavy lifting for you. The things that everybody has to do to implement security, whether it be on a network or physically controlling access to a data center or a server room. And then there are pieces that you get to make decisions about how you implement them as how is appropriate for your particular business. Do you want to expose data publicly or do you want to keep it close hold? But to repeat what I said earlier, every customer has access to the same security capabilities, which means you decide how you format that firewall, how you route packets through your network. You decide what should be exposed to the internet and what should be held only on your virtual private cloud. Now, cloud security is something that I said is very similar to what you have on premises. And it's made up of these three major themes. And this is what I'll be talking about in a little more detail. Visibility is all about understanding what you have. Auditability, of course, is understanding how we do the business of security. And control is giving you those knobs and levers that allow you to make good decisions and implement security wisely across your organization. So thinking about visibility, what does that mean? To me, visibility means understanding what you have. Because I would argue that you cannot secure what you don't know about. If you think about the conversations that we have with most of our customers, when we go into a large organization and we sit down with the CIO, and we say, okay, what about this security thing and how do I do it right in the cloud? I'll start the conversation off pretty simply. How do you know what you've got right now? That sometimes is a little uncomfortable. Many CIOs get a little fidgety and start saying, well, I've got an idea about what I have, and sometimes people pull out the outdated Visio diagram from a year and a half ago. It's got some arrows and some boxes on it. Well, it gives me an idea that there's some things here. Don't know what they are, but we're working in the right direction. Those who are more sophisticated may have inventory control systems that they use. The problem is those things are often so cumbersome and so hard to use that they're run maybe once a year. What happens on day N+1? Somebody plugs something in under their desk. Somebody plugs something in a server room that nobody knows about. And the difficulty is that over time, networks and systems accrete new pieces. You end up with something that looks like this. How many of you have been in your own data centers and see something that's a little bit familiar to you on the screen right now? A lot of hands going up right now. That's because systems grow organically over time. The good news is that when you operate in a fully API-driven environment like AWS, that is your view of your systems. Most importantly, that view is real-time, that view is always complete, And it's API-driven, which means that you can query it as often as you like. NASA JPL, for example, every 5 minutes, they query our APIs to learn what's running, to learn who started what virtual machine, what network it's connected to, and what firewall rules it has. This allows them to keep very close tabs on what's running on their infrastructure to ensure that it's meeting their expectations for configuration management control, for availability, connectivity, and security. Now, let's talk a little bit more about auditability. AWS is a global company. We have customers in more than 190 countries around the world, and those customers speak different human languages. Because we serve everything from government to gaming startups, we have to speak different regulation and accreditation languages as well. The net result is that we support many different accreditations for specific verticals or generic certifications that are more applicable across entire ranges of customers. For government customers, you'll recognize FISMA on there, where we have authorities to operate. For DoD customers, we have provisional ATOs to help you move into the cloud more successfully. And for every customer out there, we subscribe to standards like ISO 27001. All of those different certifications allow you to understand how we operate our business. Now, a couple theory points about the way AWS functions. Remember how I said that we run security to the same bar across the company worldwide? The same thing is true for our other controls as well. We use a uniform bar across the planet because it is the smart, simple way to think about security. I don't want to have our staff having to think about, well, I'm running in a data center in Dublin at the moment, so I should do this, whereas if I were running in a data center in the US, I should do that. Quite the contrary. I want them to think about one thing, do it consistently across the planet. Now, our certification process addresses the controls that are on the screen, and these are the things that you think about every day if you're a security professional, about how you control your access to data, how you understand what we do with our humans on networks, how we process the world of physical security, that's locks, alarms, gates, guards, alarm systems, and CCTV, and how we manage the integrity, availability, and redundancy of your information when you're handing it to us for safekeeping. The outcome of all of those audits are artifacts that are reviewed by our auditors, in our case Ernst & Young, who then issue an opinion about the sufficiency of operation of our security standards. Are we doing what we say we do? Why is this important? Again, it's about leverage. The same way that the student can leverage the security that Royal Dutch Shell drives, every customer can leverage the examination of our security processes that result in this particular audit report. It's about allowing you to focus on doing your business rather than having to paw through our records of CCTV systems. Let's talk a little bit more about control. Control is about giving you the ability to designate who has access to your information when, where, and how. There are parallels to the current computer world in the world of human history. If you think about where we used to live as people, quite often we would live in towns. The towns might be surrounded by walls because there were people outside those walls who wanted to come and do us ill. So when the hordes arrived, we depended on the wall to defend us. The problem was, when the hordes breached the wall, they were able to run amok inside the city, causing all sorts of mayhem. I would argue that's the same thing for perimeter-based network security. Depending on that as your sole source of security is a losing proposition. You have to think about defense in depth. Going back to the analogy, the more affluent people who lived in towns would build a keep. They might put a moat around it and staff it with additional guards. That allowed them to protect themselves. The problem was the rest of us were kind of at the mercy of whatever happened. In AWS, every customer has access to the same security controls, which means that you can write rules about who has access to your data down to very fine-grained pieces of information. So for example, I can write a rule that says, Tom is the only person who can access this S3 object. He can only access it when he's on his corporate desktop machine, between the hours of 9 a.m. and 5 p.m., and when he has a multi-factor authentication token in his hand. That's an incredibly granular piece of rule setting for a single piece of data. And customers can choose to do that as broadly or as little as they want. I want to talk a little bit about least privilege in operation. Many of you are familiar with the concept of least privilege. Least privilege is something that we practice at AWS quite consistently. And for us, least privilege is about ensuring that our staff have access to as little information as possible to ensure that they only have access to those things which are required for them to do their specific work. So for example, if I'm on the S3 team, I will only have access to the systems, the services, the physical machines that S3 runs on. More importantly, when I arrive in the company, I don't get that access automatically. My boss has to authorize me access to those systems. And every 90 days, my boss has to reauthorize me access to those systems. If he or she doesn't do so, the system automatically revokes my access. Similarly, if I transfer within the company, if I change teams, the system automatically revokes my access to that customer data. This is about minimizing that perimeter, minimizing the number of humans who can touch things. Similarly, we think about minimizing networks themselves. The corporate network that I arrive at work and I plug my laptop into is not the same network that contains your data. We know how attackers think. The most frequently exploited point of entry into any computer system is the people, the humans. The more skilled the attacker, the more likely they are to target individual humans and go after them to collect valid authentication credentials and then try and behave like that authorized person on a network. How many of you have people in your systems who are the system administrator? They've got root or admin privileges on all of the machines in your environment. Unfortunately, too many in many cases. At AWS, that doesn't exist. We don't have the system administrator. Each team has their own administration privileges, and those administration privileges are not shared across infrastructures. More importantly, we have developed networks which are independent of each other. So for example, when I log into my corporate desktop machine, I use my corporate authentication credentials. But if I were on the EC2 team and I needed to access the EC2 network, I have to use a separate set of credentials. These are based on certificates. It's not based on a username and password. Why? Because it's harder to steal. Similarly, I use a different set of authentication credentials because even if somebody compromises my corporate network and gets access to those creds, they can't use them to access the next step. Furthermore, those networks are separated by bastion hosts. A bastion host is a control point between two networks where I can force a separate authentication and authorization of that individual to ensure that they have a need to be there. And a need to be there extends into the world of data centers as well. When you ask Amazonians, where are your data centers located? Most of them will be able to tell you what geographic part of the world, whether it's Dublin, Ireland, Northern Virginia, San Francisco, Oregon, Tokyo, Singapore, China. But they won't be able to give you a physical address for the data centers. We believe, again, in need to know. Does our staff member need to know that information to do their job? If they don't get access to it. Now, security through obscurity is not sufficient in and of itself. But again, this is the application of control of information broadly throughout the organization. Furthermore, our staff have to have a business need to access the data centers if they want to be there. You cannot use your corporate credential, that card that you hang around your neck when you walk around the office, to gain access to data centers. We use a separate badging system that uses physically separate cards, that uses physically separate encryption on our data center networks, on physically separate authentication systems. Again, limiting blast radius. If somebody were somehow to do something nefarious to our corporate badging system, it would not extend to the data centers. I've been talking a lot about security controls, and one point that I want to make that's critically important here is simple security controls are key to success. If you have to have security professionals evaluating a 7-step if-then in order to make a decision, you're doing it wrong. Security should be simple, it should be direct, it should be easily understood, and it should be something that anybody can make a reasoned decision around. So the controls that we implement tend to be black and white. They tend to be yes or no. They tend to be A or B. And an example of one of those controls is on the destruction of disks. Our customers have told us that it's critically important that we assure them that their data stays safe in our data centers. At our scale, it's not a question of if a hard disk is failing. It's a question of how many thousands of hard disks are failing at any given minute and any given day. So we have, unfortunately, become very good at dealing with failed hard drives. Now, because we've given our customers a commitment to ensure that their data is safe, we implemented a simple security control. No hard drive may leave our data centers intact, period. It's super easy for our security guards to enforce. When our staff walks through that metal detector on the way out of our building, it's really easy to tell if you have a hard drive on you or not. So what do we do with all these things that we stack up and get rid of? We degauss the magnetic disks using an NSA-approved degausser, and then we turn them into the recyclable material that you see on the screen. That's shredded or pulverized, or in some cases, we use a hydraulic press to punch holes in the disk, pushing the motor out the bottom and deforming the platters. The net result is it's something that's very easy for a security guard to audit. This is not an intact hard drive. It may leave. This looks intact. It has to stay. The downside, of course, is we cannot return hard drives for warranty purposes, but that's a cost of doing business. For us, the most important thing is ensuring that the customer's data is safe. The application of these controls, the application of these capabilities, the provision of these services has meant that customers are telling us, and they're telling analysts, that they feel better about operating in an environment like AWS's than they do in their own premises. This is something that's been happening for a while. This quote's from 2013. But it's something that's fundamental, and it's something that's appearing in more and more locations. And we're hearing it from customers from small to large. And this is a quote from Tom Soderstrom, the CTO at NASA JPL, when we had a conversation a few months ago. He told me something that made me really happy to be doing the work that I am. And that's that, based on his experience, he believes that NASA JPL can be more secure in their own cloud at Amazon than they can be in their own on-premises data centers because of the visibility, auditability, and control that they gain by moving it into infrastructure like ours. So with those thoughts, I want to thank you, and I want to hope that you enjoy the rest of the couple days that you have with us, go through the learning experience, and when you run into an AWS staff member here, if you have a thought for something you'd like to see, feedback on our services, please let them know. We really value your input. Thank you.